All right, today we're going to go back over and review the oxidation numbers, molar mass, and percent composition. Remember, there was rules when we started talking about oxidation numbers, and it was we set it equal to something. But if you'll go back and you'll look at rule number 1, it says something about that if you ever have an element that is elemental, okay, it has an oxidation number of what? Is this an element by itself? Yeah, so its oxidation number is 0. And let's talk about why. Okay, oxidation numbers are telling you exactly how many electrons are what? Being shared. Is this going to share with anything? No, iron is not going to share with anything, therefore its oxidation number is 0. So anytime you see something like that, when it's by itself, it's always going to be 0. What if I had something like this? Now, we talked about this being twins. Even though they're twins, are they going to share? No, exactly. So both of these would be 0. Okay, iron and oxygen would be 0 because they're not going to share. The only time they're going to share is when they are in a specific compound. All right, so let's move on to this next one, potassium nitrate. Now, Jonathan, what am I going to set this one equal to and why? This one. Is it neutral or charged? So you set it equal to 0. Okay. This potassium nitrate has no charge, right? There's nothing there, but look right here. What's right there? Does that make sense? So what would this one be set equal to? 0. This one be set equal to 0, and this one will have a charge, and whenever we get over there, we'll see it. Okay, we're going to set this one equal to 0. Now, oxygen in this case is going to have an oxidation number of -2. We agree with that? Now, metals charges come from what? Their group number. Okay, well, what group number is potassium in? It's in 1, so what's this number? Or what's this oxidation number? +1. Now, mathematically, what are we going to get right here? -6. What are we going to get here? +1. And so mathematically, what is the only thing that will make this sentence true? +5. Calvin, you have a question? Okay, you good? Okay. Now, nitrogen has to give away 5 electrons. Now, if there's one nitrogen, how many does it have to give away? All 5, right? So, look at the statement, the instructions. Determine the oxidation numbers for the underlying element. So, what would your answer be for this question? +5. That's all you would put is +5. So nitrogen, this one nitrogen is going to give away 5 electrons. Now, Cade, how do you know it's giving away and not taking in? It's positive, exactly. So positive means you give off. You are losing those electrons. So it is positive. Very good. All right, let's move on to the next one. This one is set equal to this one's going to be set equal to what? Good, -2 because it has a charge of -2. Now, oxygen in this case is going to have an oxidation number of what? -2. Mathematically, bring this down. This is -8. Okay. What is the only thing that can make this sentence possibly true? Now, be careful with what you're thinking. Okay. Emily, what is it? What kind of 6? +6. Now, this is very important whenever you're doing this. You have to make sure you say positive or negative, not just 6. Now, every carbon the total number of electrons given away by carbon is 6, but there's 2 of them. So how many does each one give away? 3. Very good. So this is +3. Okay, so that will be your answer for this. Yes, sir. Yeah, -2. So you have -2 times 4 gives you -8. Now, remember, if you want to look at it another way, once you get this statement true, what you can do is you can do 6 divided by 2. Now, where did that come from? Okay, you have this number and that number. Does that give you 3? Yes, so you can do it either way. You can say, well, there has to be a 6 total given away, and how many is there to give 6 away? Well, there's 2, right? Okay, Bryce, if me and you have to give 6 things away, what would make it equal for us to give away each? 3. Does that make sense? Because there's a subscript of 2 there. So you just divide. So 6 divided by 2. Because each carbon is going to give away 3 each for a total of 6 given away. No, this is just for your math. The final answer would be plus 3. This is the math to let you know what that number is. Okay? All right. So this time we're going to look at strontium sulfite. Now, how do I know this is sulfite? It's SO3. What's sulfate? SO4. Very good. Okay. What am I going to set this equal to? 0. Oxygen in this case is -2. So mathematically, this is -6. Very good. Strontium is in what group? 2. So its oxidation number is +2. Mathematically, bringing this down, you're going to get a +2. Okay. Katie, what do you get right here? +4. Very good. So this is a +4. Now, every sulfur, or the total number of electrons given away for sulfur is +4, but how many sulfurs are there? 1. So how many does the sulfur have to give away? All 4. So what will be your answer in this case? +4. So sulfur gives away 4 electrons. All right, moving on to the next one. This one is UF6, so set this in equal to 0. Now, we've got fluorine this time. What is its oxidation number? -1. Why is it -1? It's a group 17, and it's the most electronegative. So set this equal to -1. Mathematically, this is -6. Calvin, what's the only thing that makes that true? Very good. +6. And since there's only 1 uranium, how many does it have to give away? All 6. And that is your answer. Okay. Any questions on any of this? Any questions? I think there's one more that I wanted to look at because I think it was a little bit different. All right, yeah, this one right here. Let's look at 7 and 8 real quick. Nisha, what am I setting this one equal to and why? Very good. Why is it -1? Because it's got a negative charge. Very good. Okay. Lexi, what is oxygen in this case? -2. Mathematically, Liz bringing that down, that is -6. So Caroline, what's the only thing that makes this true? Very good, +5. So Michael, what does chlorine have to be? Very good, +5. All right, so again, that's the answer. Now, if you have your rules out, number 8 is kind of different. Now, I'm not going to give you one like this on the test, but I do want to show you this just so you are aware that this is possible. Now, we've always said that according to our rules, that hydrogen is a +1 unless it's with a what? Unless it's with a metal. Is this a metal? Then what is it in cases and when it's with a metal? It's a -1. Okay? Again, I'm not going to give you something like this. So hydrogen.
Mr. Richard?
So hydrogen, again, in this case, is going to equal. Oops. All right. Hydrogen, in this case, again, is going to equal a -1 because it's with a metal. Okay? Hydrogen is a -1. The whole entire thing is going to be set equal to 0 because the compound is neutral. Does it make sense why it's neutral? Because it does not have a charge. Does it make sense? Okay. So now, what is that mathematically going to bring down to be? -2. What does this have to be to make sense? +2. Now, we honestly could have figured this out. Why? Because what group is calcium in? 2. Okay. What does metals charges come from? Group number. So does it make sense how you could have done this without even knowing what hydrogen was? But it has to make sense. So even if you knew what this was, you could have mathematically figured that out either way, however you approach this. But we know that this is a rule. Okay, so we could have approached it from either way. Calcium is a +2 because that's this group number, or hydrogen is a -1, and you can mathematically figure it out. So again, I just wanted to show you that again. I'm not going to give you one like that on the test, but I did want you to be aware of those situations. Now, I'm not going to work any of these because I think that y'all have these without any problems at all. So we're going to go down to the bottom ones. One of the good parts about this is that we've done this so many times and we've done this before that it's easy, and you should know this. And I just want to write this up here to remind you. Remember, we can go from grams to moles and then to molecules to atoms. Now, the thing that we left off with last time is, remember, we mathematically proved that if we're going from one compound to the same compound, first of all, is KF and KF the same compound? Yes. Do we have to go to moles? Remember, luckily we have that rich uncle that flies us straight from grams all the way to molecules and atoms. We don't have to do that because, remember, the ones cancel out, okay? The ones will cancel out, so you can just move everything over. So if in this case they were asking us to go from grams to molecules, we could do that, or vice versa. But this time they're not. They're asking us to go from moles to grams. So it's a simple one-step conversion. So 0.96 moles of KF. Now, if moles is on top, where does it have to go? On the bottom. Okay, and we're going to grams. Now, Bailey, if moles is in parentheses, where does it come from? Or what is it? A 1. Cade, where does your grams come from? Periodic table. Somebody help me out real quick with the math on that. Thank you, sir. 58.1. So, mathematically, Janasia, multiply, divide, add, subtract. Why are you multiplying? It's across straight across the top. Very good. Now, this is a very good question. Logan, significant figures. 2. Very good. So your answer must contain 2. Anybody got that? 56. Now, if you left it like that, is it right or wrong? Wrong. If you leave it in grams, is it right or wrong? Wrong. And then we need to go to grams of potassium fluoride. That should be your answer. Any questions on that? Okay, should be very, very, very simple. Let's move on to the next one. Any questions before I do move on? We good? All right, that's a good question, Bryce. Why is it not grams per mole? What does the question say? It says grams of KF. Now, also, another way to look at it, if moles is up here and moles is up here, what are they going to do mathematically? They're going to cancel, so the only thing you're left with is grams. Okay, does that make sense? Okay. Very, very good. So 1.98 grams of, in your head, name that. Thanks. In your head? Calcium chloride it is, yes. Okay. Now grams is on top, so grams must go to the bottom, and they want us to go to moles. Okay. We know that moles gets a 1. Does anybody have the mass of calcium chloride? Should be 70.90 plus 40.08. Thank you, sir. 119.98. Okay. Now, Libby, mathematically, multiply or divide? Okay. Remember, if it's on bottom, you divide. Right? Very good. So divide across the bottom. Now, Aaron, how many significant figures are right there? 3. Very good. So your answer must contain 3. Sophia, you got an answer? So, well, hold on, hang on. The mass is wrong. So 110.98? Okay, sorry. So change this to 110.98. Now let's redo it. Janasia, you got an answer? What is it? 0.0178. Now, moles of what? Now, why is it not dichloride? Very good. Metals do not have prefixes. Okay. Any questions? Now, this one is honestly the exact same thing as that. The only thing is going to change is your mass. Okay. It's just going to be a much bigger mass. Same thing as here. Okay. Hold on. No, this one actually goes to molecules. So let's look at this one. I thought that said moles to begin with. All right. So let's look at number 4. So 9.8 grams of P2O5. Carly, can you name that? Okay, is this covalent or ionic? Is that a nonmetal? Yeah, it's a nonmetal. Name what you see. Phosphorus. How many? So it's diphosphorus. Think about that. Pentoxide. All right, let's put that together. Diphosphorus pentoxide. Thank you very much. All right. So now, are we going from one compound to the same compound? Yes. So can we skip the mole step? Yes. Very good. I want you to make a little note of that. So since we're going to the same compound, you can skip the mole step, because in chapter 9, whenever we go from one compound to a different compound, that mole step's going to have to come back into play. And again, it's adding one step back into it. This just as easy, okay? But I just want to make sure that you know that since we're going to the same compound, you can skip it. But when we start changing compounds, you've got to recognize that you cannot skip it. So 9.68 grams of diphosphorus pentoxide. Okay? So we're going grams to, I'm just going to abbreviate this, cules. Okay? Now, anybody have the mass of that yet? Thank you. Does everybody agree? 141.93. 94. Sorry. Okay. Maddie, when you have molecules in parentheses, what goes beside that number? Or that molecules, not moles. That big ugly number.
Oh, that's 6.02.
Whose number is that? Olive? No, it's not Braden's number. It's Avogadro. Okay? Avogadro, 6.02 times 10 to the 23rd. Now, say that again. Yes, that's always going to go beside molecules, is Avogadro's number. Now, let's do this. I want to help you guys out so you can see it. Let me pull up the calculator. Okay. All right. So remember, the reason I'm pulling this up is because of the exponent. So I just want to make sure you get it. So 9.68 times 6.02 EE 23 equals divided by 141.94 equals. Now, how many significant figures do I have in my given? 3, so I need 3. So it is going to be 4.12 times 10 to the what? Wow, I really messed that up. I'm sorry. Okay, so 4.11. I have no idea what I was thinking there. So 4.11. Very good. If you got that, fantastic. 4.11 times 10 to the 22nd. Now, can you leave it like that? No, it's going to be molecules of diphosphorus pentoxide, P2O5. So how many of you feel confident in doing this? Okay, it's really not that bad. It's not that bad. It's just making sure you know from what you're going to something else. All right, I want to work one more example, and then I'm going to move on to something else that's this further down this that we have not done yet. I tell you what, let's do this. You guys do number 5 by yourself, and we'll work it, and then we'll come back and look at another one. So 1.69 times 10 to the 24th molecules. Now, I mean, I know it's going to say molecules, but I don't have the space to write that down. So now, molecules is going to go on bottom. Why? What do we need to do? To cancel out, and we want to go to grams. Now, you should know this. I've asked you to memorize this several times. The mass of water is 18.02. What always goes beside molecules? Good. Avogadro's number is 6.02 times 10 to the 23rd. Now, let me ask you this. I'll need this to make sense to you. Mathematically, should this and this cancel? Yeah, they're going to. So what I'm saying is, when you get your answer, it's not going to be times 10 to the something, right? Because we're going to grams. Grams has got to be a much smaller number. So let's look and see what happens in the calculator, because I want you to be able to think for logic here. Okay? I want you to be able to check for logic. All right, let me clear this. So 1.69 EE to the 24th times 18.02 equals, divided by 6.02 EE 23 equals. Now, sig figs, how many do we need? 3, so what should your answer be? 50.6. How many of you got that? Fantastic. If you did not, was it a calculator problem? Okay. 50.6 grams of H2O. So what we're going to do is we're going to move on, but I need you to go back and work and see if you can figure out how to get that every single time. 50.6. Okay, 50.6 is what you need to get every single time. All right, the reason I need to move on is because I'm almost running out of time, and I really need you to see number 8. It's really, really, really important. Yes, ma'am. Yes. Okay, just these 3 things we've covered today. Now, you should be able to do molar mass because we've been doing it in this, and you should be able to do percent composition because remember, percent composition is part divided by whole, and just divide all those parts by the molar mass, okay? All right. So number 8, I want you to notice this. Are these the same thing? No, they're not. But is the F a part of the SF6? Yes, it is. So what they're asking us is if I have 38 grams of sulfur hexafluoride in that 38 grams, if I could count them, how many fluorines will be present? Okay. Now, that's in one of those, but there's 38 grams worth. So it's not just 6. Does that make sense? Because we need to figure out how many SF6 it takes to make up 38 grams. Now, if I ask you this, if I had 38 grams of salt, would it be 1 NaCl? No, it would be how many? 30. It would be 38 grams worth, right? So we got to figure out how many molecules this is. So that's the first thing we want to do. So let's convert this to molecules because we need to know how many molecules it takes to make this step up right here. So 38.0 grams of SF6. Now, can I go grams to molecules? Have we been doing that step? Okay. So let's do that step. Somebody get me the molar mass of SF6 or SF6. Now we know what goes beside molecules. What is it? That sounds about right. 19 times 6 plus 32.06. Okay. 146.06. 146.06. Say that again. Exactly. Now, here's my question to you. What is the question asking you for? Atoms of F. We are at molecules. Is that what we need to be in? No. Michaela, this must make sense. If we're not at where we're at and molecules is on top, what must go on the bottom? Molecules. Regardless of if you know where we're going, this must be true. Why does that have to be true? What are we trying to do to molecules? We've canceled grams. Now we got to cancel molecules. Now, this is where it's got to make sense. Is F a part of SF6? That's your question. Go ahead.
I was thinking on the mass, you multiply S and F together to get the mass. It could
Just do the mass the normal way. Yeah, just do it normal. Is that not the right mass?
I don't know. I was just saying.
Okay. Now, is this a molecule? Is that one molecule? Okay, follow along with me. This is one molecule. How many F's are in that one molecule? Think about it for just 1 second. So we got rid of molecules. So we need to know how many F's are in this amount. So in 38 grams, we need to know how many F's there are. Well, we figured out how many molecules there are. Now, in that number of molecules, we need to know how many F's are present. Okay, so think about it mathematically. Have grams canceled? Yes. Have molecules canceled? Yes. Are we at where we need to be? Atoms of F. Yes, we are. Hypothetically, what if this said atoms of S? What number would be right there? A 1. So do you see the relationship there? Okay. If we were using this thing and it said O, what would be in that blank? 5. If it said nitrogen, what would be in that blank? 2. So again, it's just a relationship of how many are present in this thing. So mathematically, what are we going to do across the top? Multiply. What are we going to do across the bottom? Divide. So let's pull up the calculator and let's see how it works. All right, let's clear this. So 38 times 6 times, I know I did it backwards, just did it easier for me to punch it in. Avogadro's number. So we good with this idea? Hang on, okay. No, yeah, we're good. So 38 times 6 times 6.02 times 10 to the 23rd. Then what are you going to do to that number? Divide it by what? 146.06. And when you get that, we need 3 significant figures. So 9 point, what is that? 40. Very good. 40 times 10 to the 23rd atoms. This is a 3. Atoms of F. So if I have 38 grams of sulfur hexafluoride, there are going to be that many atoms present. Okay, that's a lot of atoms of fluorine. It's a lot of atoms of fluorine. Any questions? All right, I want you guys to practice number 9, and then we're going to give the answer later. Okay. All right, so 4.62 grams of H2O. Okay, I know that grams has to go on bottom. That's 18.02. Okay, I know Avogadro's number has to go on top. And this is actually not a good question, and the reason why is because back here we get molecules. And in one molecule of water, how many oxygen are there? 1. So really, mathematically, there's not going to be any math there. So when you multiplied this, what did you come up with? Or when you did the math here, what did you come up with? Okay, so the 3 sig figs, 1.54 times 10 to the 23rd. Okay, and that would be atoms of oxygen. Okay, 1.54 times 10 to the 23rd atoms of oxygen. Okay, guys, don't forget tomorrow, again, it's just oxidation numbers, molar mass conversions, and the percent composition.